Hello. In this video, what we're going to do is look at question 11 from homework 8. We did several examples like this. Well, we did a couple examples like this in the lecture video, but unfortunately, the WebAssign only has one homework question that I can ask about this, and this is a little bit harder than I wanted it to be. So what we're going to do is I still want to go through the problem, but we'll go through it together. So what the question asks, we start with a function f of x equal to arcsine of e to the x and we have three questions we want to answer. We want to find the derivative, we want to find the domain of the function, and we want to find the domain of the derivative. And what we noticed in the lecture notes was that often the domain of the function and the domain of the derivative are similar. It's just that the domain of the derivative leaves out any endpoints. So let's see if this fits the same pattern. We'll answer these questions in order. So the first thing we want to do is find the derivative. What rule should we use to find the derivative of arcsine of e to the x? This is a function with an inside and an outside part, so we are going to use the chain rule. So let's, start by identifying our inside and our outside part. Our outside is the arcsine, and our inside is e to the x. Okay, I need to find the derivative of each piece. For arcsine, and the derivative of arcsine of x is 1 over the square root of 1 minus x squared. And e of x, that's one of our old rules. The derivative of e to the x is e to the x. So here are our pieces for the chain rule. Putting them together, it tells us that the derivative of our original function is f prime of g, so I'm going to plug g into f prime. Times g prime, so times e to the x. And I can combine this and write it as a single fraction. That's the same as e to the x over the square root of 1 minus e to the x squared. So there's my derivative. Okay, the part of the question that I want to focus on, though, is parts 2 and 3, finding the domain of the function and its derivative. So let's start with the original function. So part 2, so we want to find the domain of, and let me rewrite the original function, it was the arcsine of e to the x. Okay, for inverse trig functions, we're going to start by figuring out what quantity is allowed to go inside that inverse trig function. So for arcsine, its domain is all the numbers that appear as the sine of different angles on the unit circle. Well, the only things that I can get as the sine of an angle are the numbers between -1 and +1. So what I need is I need that input, e to the x, to be between -1 and +1. And I want to solve this inequality for e to the x. Sorry, I want to solve this inequality for x, just x, which means that I need to get that x out of the exponent, and the way I'm going to do that is by taking the natural logs. But I run into an issue because I can't take the natural log of -1. So I have to think about this slightly differently. First off, e to the x can't be -1. E raised to a power is always positive because no matter what exponent I take a positive number to, I can't get a negative number. And you can actually see that, if you prefer, in the graph. The graph of e to the x crosses here at 1. It's got a sharp increase to the right, and to the left it decays down to 0. So here's my graph, and you can see that no matter where I am on this x-axis, I'm never going to get a negative y value. In fact, I'm never even going to get 0. I have an asymptote at 0 that I just approach. So my y values on this graph are always going to be positive, which is another way of saying e to the x is always greater than 0. So really, I can trade out this inequality for a more specific one. I'm really looking for the x values where 0 is less than e to the x, and that's less than or equal to 1. Okay, I still can't take the natural log of everything, but if I combine this information for what I'm looking at with my graph, I said this point where x is 0 is where I cross at a height of 1. I'm looking for the points on the graph where y, the e to the x value, is less than or equal to 1. Well, that's the left half of the graph. And if I look at my left half, all of the y values are less than 1, and as x gets further and further to the left, I'm approaching the 0. So they're all going to be less than 1 and greater than 0. On the right-hand side, all of my y values are bigger than 1 because of this exponential growth. So really what I'm looking at are the x values on the left half of my graph. Well, those are the x values on the left that are negative, so less than or equal to 0. And WebAssign wants you to write that as an interval. So as an interval, these are the x values from -infinity to 0. So there's the domain of my original function. And just to recap what we said, we started by observing that whatever I plug into the arcsign has to be between -1 and +1. In this case, the thing that I'm plugging into the arcsign is always positive, which gave me this inequality here, that I really needed that e to the x to be less than or equal to 1. And the easiest way to think about this is to go to the graph. That happens whenever I'm on the left-hand side of the graph. And the left-hand side corresponds to the x values that are negative, or less than or equal to 0. So that's my domain, are the x values that are less than or equal to 0, which I can write as an interval in this way. Okay, so that's the domain of my original function, and we always have the suspicion that the domain of the derivative will be similar, but let's double check that. So part 3 is to find the domain of the derivative. Let me again recall what the derivative was. We figured out in the first part that the derivative of this function is e to the x divided by the square root of 1 minus e to the x squared. Okay, so we want to think about what can go wrong. The first thing that can go wrong is I could end up dividing by 0. So I need to make sure that I don't divide by 0. Which really means that the stuff inside the square root can't be 0, because if I take the square root of 0, I get 0, and that means that I have 0 in my denominator. So that tells me that 1 minus e to the x squared can't be 0. The other thing that could go wrong is I could take the square root of a negative number, so we need to avoid that. What that means is that the stuff inside the square root has to be greater than or equal to 0, so I end up with 1 minus e to the x squared needs to be greater than or equal to 0. Combining these, the condition that I get is that for an x value to be in the domain, what I need is 1 minus e to the x squared to be strictly greater than 0. This says it has to be greater than or equal to 0, but this says it's not allowed to equal 0, so the only possibility is for it to actually be bigger than 0. Okay, and this, believe it or not, is similar to the questions that we answered in the lecture, but we have that e to the x, which is going to make things a little bit messier. So to solve this, we're going to start by hiding the e to the x. We're going to make a substitution. Let's call that e to the x a. Then my inequality becomes 1 minus a squared is greater than 0. And I want to solve this for a. I go through my steps for solving a polynomial inequality, which starts by finding zeros. And I do that by factoring. The way that I factor 1 minus a squared is using the difference of squares patterns. That's 1 minus a times 1 plus a. And I want to know where that's actually equal to 0. And I get two places. It happens at a equal to 1 and at a equal to negative 1. For this type of inequality, then, I set up my number line. Where I divide the number line at my zeros, and then I test points. So my number line will look like this. I have a break at negative 1, and I have a break at 1. And the thing I'm looking at is this 1 minus a squared. I want to know where that's positive and where it's negative. I need to test one value in each of these three regions. Let's start with 0, because that's always simple. If I plug in 0 for my a to 1 minus a squared, do I get a positive or a negative value? I get a positive value, because 1 minus 0 squared is just 1, so that's positive. Okay, let's test 2. And it's the same question. If I plug in 2 to the equation 1 minus a squared, do I get a positive or a negative value? And this time I get a negative value. Okay, one more region. Let's test over here at -2. If I plug -2 into 1 minus a squared, do I get a positive or a negative? I get a negative number again because 1 minus -2 squared gives me a 1 minus 4, which is -3. So negative. What this tells me is that 1 minus a squared is positive between -1 and +1. It's 0 at these two places, and it's negative everywhere else. So if I scroll up, actually it's right here, what we were looking at were the places where it was strictly positive. So this tells me that the values of a that I want are -1 to 1, this time not including the two endpoints. -1 and 1 don't work because that makes it equal to 0, not positive. Okay, so I figured out what my values for a are, but remember a was a stand-in. A really stands for e to the x. So what I want is to go back and figure out what this tells me about x. Well, it tells me that -1 should be strictly less than e to the x, and that should be strictly less than 1. And again, if I think back to the graph of e to the x, here's my height of 1. It increases to the right and it decreases to the left, approaching this asymptote at y equal to 0. So one thing I see again is that e to the x, the y values that I get, are always positive. So this is really redundant. I can say that 0 is less than e to the x is less than 1. So I'm looking for the x values on my graph, where the corresponding y value is between 0 and 1. And I can see that sort of my tipping point is again at x equal to 0. For everything to the left of 0, x is going to be less than 1. At 0, e to the x is equal to 1. And to the right, e to the x is greater than 1. I'm looking for the places where e to the x is less than 1, so I'm looking again at the left-hand side of my graph. The left-hand side is where x is negative, so my domain will be all those negative values. And the only difference between this domain and the domain we found above is that this time I'm not including 0, because at 0 e to the x is equal to 1, and I wanted e to the x to be less than 1. So everything less than x equal to 0 works. Sorry, this should be a 0. Everything on the left-hand side of my graph works, but 0 does not. So I have to exclude that, and that means that I use this round parentheses when I write my interval.